In this chapter, you learn define atom, state the law of conservation of mass, list important features of Dalton's atomic theory, distinguish between atoms and molecules, define atomic mass and molecular mass, define the mole concept and molar mass, define atomic mass and atomic number, represent some molecules with the help of a formula, and solve simple problems based on various concepts learnt. Let us understand what do you mean by atom. So in short, we can say atoms means indivisible. Atoms means it means that it is a so smallest particle. Atom is so smallest particle that it cannot be divided further. You will reach a stage. Suppose if you take a piece of a chalk and if you go on dividing a chalk and you reach a stage that you cannot divide it further. Such a small piece of a chalk you can say is an atom. Practically, we cannot see the atoms. It is not possible to see the atoms. They are so smallest particle that we cannot divide them further. So we say that atoms means indivisible. In another way, we can say an atom is the smallest unit of ordinary matter that forms a chemical element. Every solid, liquid, gas, and plasma is composed of neutral or ionized atoms. We already studied that atoms are indivisible. At the same time, it is a smallest unit of matter. Whatever exists in the nature, whatever is present in nature, that which occupies a space or volume, the matter is made up of a smallest unit called as an atom. So, atom forms a unit of a solid, liquid, gas, and plasma. It is present in all the states of matter. So on the right side, you can see the diagram of an atom. Though we say that atom is the smallest particle, but at the same time, atom consists of some of the subatomic particles. It consists of smallest particles within it. So let us study what are those. So these particles which are present within the atom, they are called subatomic particles. They are proton, neutron, and electrons. Right? So these three are the subatomic particles: protons, neutrons, and electrons. Protons and neutrons are present at the center of the atom, which forms the nucleus. We call it as a mass of an atom. And electrons, which are revolving around the nucleus. They are revolving around the nucleus in a specific path. And these paths are called as electron orbits. These paths are called as electron orbits. So this is, we can say, the gross structure of an atom. We will study about the law of conservation of mass. Every chemical reaction, total masses of all the reactant is equal to the total masses of all the products. So this was been proposed by the scientist Anthony Lavoisier. So what did he propose? He said that in every chemical reaction, the total masses of all the reactants will be equal to the total masses of all the products. So the reactants will be on the left hand side and the products will be the right hand side. These two will be separated by an arrow mark. So let us see with help of an example. So below you have an example of calcium carbonate, CaCO3. So here we can say that 10 grams of CaCO3 is a reactant. So we have the total mass of reactant is 10 grams. Now on the right hand side we have 3.8 grams of carbon dioxide plus 6.2 grams of calcium oxide. So these two are the products. So when we sum up the 3.8 plus 6.2, according to the law of conservation of mass, we should get 10. So that's what the law of conservation mass states. So exactly when we add up the 3.8 and 6.2, we get 10 grams. So this was being obeyed by all the chemical reactions, which was been proposed by Anthony Lavoisier. He said that the total reactants mass will be equal to the total product mass. So that was nothing but the law of conservation of mass. Even the law of conservation of energy states the same. What does it states? Energy can neither be created nor be destroyed. It remains constant. Similarly here, the mass remains constant. The total mass of reactant is equal to the total mass of products. We will now move on to the next very important topic, that is Dalton's atomic theory. So John Dalton's, we already studied some of the postulates of Dalton's in atomic structure. So we will study in detail what are the postulates of Dalton's atomic theory. So he has given his 5 postulates about the atom. So firstly, matter consists of indivisible atoms. Every matter, whatever exists in this nature, which occupies a space and has volume, we consider it as a matter. So all the matter consists of indivisible atoms. So we can say that atoms exist everywhere according to the Dalton. Second postulates, it states that the atoms of chemical element are identical in mass and in all other properties. So if we take an example of any element, say for example sodium. So the atoms of the sodium are identical in mass. All the atoms of sodium has same mass and they have the same properties. So this was being identified by the Dalton. So they have same chemical property and identical in mass. Thirdly, different chemical elements have different kinds of atoms and have different masses. Like if we take the two chemicals, say for example, take an example of a base and an acid, or you just take an example of a sodium and chlorine. So sodium elements have different kind of atoms, chlorine element has different kind of atoms. So that's what he said, that different chemical elements have different kinds of atoms and different masses. Fourth, he said atoms are indestructible. They cannot be destroyed and retain their identity in chemical reactions. Whatever may be the condition, the atoms, if they undergo any chemical reaction, they do not change their identity. We cannot destroy an atom. So that's what his fourth postulate given by the John Dalton. Lastly, he said that atoms of different elements combine in fixed whole number ratios when forming compounds. So this is very important. We already discussed in atomic structure. So atoms of different elements combine in fixed whole number. They do not combine in a fractions. Say for example, I told you that is H2O. 2 hydrogen combines with oxygen. We cannot say that half hydrogen will combine. Not possible. They always combine in a fixed whole number ratios while forming the compounds. So these were the 5 important postulates given by the John Dalton about the atom. Next, we will move upon to the very important concept, that is atomic weight. The total weight of an atom is called the atomic weight. Atomic weight is measured in atomic mass unit. It is also called as Daltons. So very simple, the weight of an atom is called as an atomic weight, right? We have atomic mass that is different from the atomic weight. So here the weight of an atom is called atomic weight and it is measured. How it is measured? It is measured in a unit called as atomic mass unit. Like we have different measurements for different matter. Say liquid is been measured in a form of a liters. Similarly here, the atom is being measured, atomic weight is measured in a form of atomic mass unit, and we have another, it is also called as Daltons. Secondly, what do you mean by atomic number? Very simple, the number of protons in the nucleus is called as atomic number, which is denoted by Z. We can also say the number of electrons present is called as an atomic number, because always the total number of protons will be equal to the total number of electrons in an atom. So the number of protons present in the nucleus is called as an atomic number, and it is denoted by the letter capital Z. What do you mean by isotopes? Atoms of an element that have same atomic number but different mass number are called as isotopes. So we have elements, they will have in nature, they will have a same atomic number, but they will have the different mass number. Let us see with help of an example. Like for example, you have carbon-12 isotopes. So here the carbon-12, the carbon is having an atomic number 6, but it has 3 different mass number. Say that is carbon-12, carbon-13 and carbon-14. So these have same atomic number, but they have different mass number. So we can say they are 3 isotopes of the element carbon with the mass number 12, 13, 14 respectively. So we can call this as an example for the isotopes. We will understand what is the differences between an atom and a molecule. That is, distinguish between the atoms and molecules. Firstly, we will understand what do you mean by a molecule. So, 2 or more atoms chemically bonded together. Right, very simple, 2 or more atoms chemically bonded together. You can see a picture at the right side. You have a picture of a molecule and an atom, right? So what happens there? There are 2 or more atoms are being combined. In case of a molecule, 2 or more atoms are being chemically bonded together. So we have an example, that is O2, oxygen, phosphorus, P4, and water, H2O. So here 2 atoms of oxygen will chemically bonded together to form a molecule, O2 molecule, oxygen molecule. And 4 phosphorus atoms will combine together. It is not the thing that only 2 or more atoms can combine. So here 4 phosphorus atoms will combine to form a phosphorus molecule. Lastly, 2 hydrogen atoms will combine with 1 oxygen atom to form a molecule, that is a water. So next we will see what do you mean by an atom. So atom is the most fundamental and smallest part that can exist of an element. So it is one of the smallest part of an element. Atom is one of the smallest part of an element, whereas the molecule will have a smallest part, that is an atom. Right? So molecule consists of an atom, whereas an element consists of an atom. This is a basic difference between a molecule and an atom. Let us see some of the examples for atom, that is oxygen, phosphorus, and hydrogen, H. So these are some of the examples for atom. So atoms togetherly forms the molecule. What do you mean by molecular formula? Molecular formula of a compound is used for determining the molecular mass of that substance. So we have formulas. So molecular formulas of any compound is used to determine the molecular mass. It gives a clear picture about the molecular mass of the substance. That is by the help of molecular formula. A molecular formula consists of chemical symbols for the constituent elements followed by number subscripts describing the number of atoms of each element present in the molecule. So a molecular formula will give the symbols. It gives a chemical symbols of a particular constituent element, and that symbol will have a number subscripts. So these subscripts will give you a description about the number of atoms present in each of an element of that molecule. Let us see this with help of an example. So for example, I have taken a very simple example, H2O, water molecule. So here, according to the above definition, here we have two chemical symbols. What are those? That is H and O. And it is followed by a subscript. What is a subscript here? 2, right? So here, the two subscripts will give us an information that water molecule contain 2 hydrogen atoms and 1 oxygen atom, which are being connected by the covalent bonds. So we get a clear idea by seeing a molecular formula. We get a clear idea about the constituent of any molecule or a compound. That is, what all are the elements present in a molecule or a compound with the help of a molecular formula. We will understand about mole. What do you mean by mole? A mole is the measurement of amount of a substance. So very simple, it is a measurement of a amount of a substance. We have different units for the measurement of a amount of a substance, but in chemistry, chemically, mole is being used for the measurement of a amount of substance. So what it is exactly? A mole of a substance or a mole of a particle is defined as containing exactly 6.022140076 into 10 to the power of 23 particles, which may be atoms, molecules, ions, or electrons. So whenever we want to say, suppose if you measure any substance, say for example 1 kg of sugar, say 1 liter of water, to measure the chemicals, right, we use a unit, that is a mole. So what do you mean by mole? So here 1 mole, in the sense it consists of how many particles? 6.022140076 into 10 to the power of 23. In the short, we can say 6.023. No need to read such a long numerical. We can say 6.023 into 10 to the power of 23 particles. What are these particles means? They may be atoms, they may be molecules, or ions, or electrons. Whenever I say that is 1 oxygen, 1 mole of oxygen, it means that it consists of 6.023 into 10 to the power of 23 particles in it. So here we use the mole for the measurement of amount of a substance, of a chemicals. So what do you mean by molar mass? Mass of 1 mole of a substance. We have studied what is a mole. That is, it is used to measurement of a substance. Now its mass is called as, that is, mass of 1 mole of a substance is called as its molar mass. Mass of 1 mole of a substance is called as a molar mass. Molar masses are almost always expressed in gram per mole. So we have a certain unit. How do we express it? We express it in a form of grams per mole. However, the SI unit used is kg per mole. Usually we will use gram per mole, but SI unit is kg per mole. Like for example, If you want to say the molar mass of a water molecule, what is the molar mass of a water molecule? It is 18 grams per mole. Like oxygen is having a mass of 16 grams, H2O, right? What is the formula for water? H2O. So it has 2 hydrogen. So mass of hydrogen is 1 gram. That is into 2. 2 grams plus 16 grams, we have 18 grams. Total molar mass of a water is 18 grams per mole. This is how we will use the molar mass. We will understand what do you mean by valency. So very simple and precise definition, we can say combining capacity of an element is called as its valency. Exactly. Any element will combine with another element and its combining capacity is because of its valency. So let us see this with the help of an example. So here you have an example of an atom, that is carbon. So here the carbon is having the atomic number, that is 6. What is the atomic number of carbon? 6. So atomic number in the sense I can say protons are 6 and here neutrons are also 6 at the same time. No issues. And electrons will also be 6. As I told you, the number of protons will always be equal to the number of electrons, right? So atomic number is 6 means the number of electrons will be 6. So coming to its electronic configuration. So first shell, as we have discussed already, the first shell will have 2 electrons. That is, they are been showing inside, right? Blue 2 balls, right? So those are 2 electrons in the first shell, say K shell. So the left out from the 6 is 4. From the 6, the left out is 4. The other 4 will get distributed in the outermost shell, that is L shell. So here, what do you mean by valency? That is the number of electrons present in the outermost shell. So how many electrons are present here? 4. So what is the combining capacity of carbon here? It is 4. It has a capacity to combine with 4 atoms. When you see here, the carbon is combining with 4 hydrogen. That is 4 hydrogen, resulting in a formation of a compound called as methane. So what is the formula for methane? It is CH4. So single carbon can combine with the 4 hydrogen atoms. So its combining capacity of an element carbon is 4. In other words, we can say the valency of carbon is 4. So in short, we can say combining capacity of an element is called as valency. We will understand about the Avogadro's number. So what is Avogadro's number? Avogadro's number is defined as the number of atoms in exactly 0.012 kg or 12 grams of carbon 12 atom, and it is always equal to 6.02 into 10 to the power of 23. So we have a constant for Avogadro's constant. It has been written as 6.02 into 10 to the power of 23 per mole. So Avogadro is a scientist. He has given his constant saying that the number of atoms present in a standard atom, he has taken a standard atom, that is carbon 12 isotope. Why did he take carbon 12 isotope? Is because it is one of the most abundant element in the nature. Carbon exists everywhere. So he has taken carbon 12 isotope. What did he say? That the number of atoms present in 12 grams of carbon 12 isotope, which is equal to 6.02 into 10 to the power of 23, is called as Avogadro's constant, or it is also called as Avogadro's number. So in short, we can say what is the Avogadro's constant? It is 6.02 into 10 to the power of 23 per mole. So we will see this with the help of an example. For example, the molecular weight of oxygen. So what is the molecular weight of oxygen? It is 32. So 1 gram of 1 gram mole of oxygen has a mass of 32 grams. In other words, we can say 1 gram mole of oxygen contains 6.02 to 14076. As I told you, we can say 6.023 into 10 to the power of 23 molecules. So we learned that 1 mole, in the sense it is a standard which is used to measure, and Avogadro has given his constant. Instead of using the mole, we can say that it consists of 6.023 into 10 to the power of 23 molecules. We will move to the question and answers part. The atomic mass of a sodium is 23. The number of moles is 46 grams of sodium. So they are given the atomic mass. What is the atomic mass? 23. So what are the number of moles present if we have a 46 grams of sodium? Is it 4 moles? Is it 2, 0 or half? So here mass is 23 and the mass given is 46 grams. They are asking what are the number of moles? Yeah, Varsha, very good. It's 2. So it's very simple. Atomic mass is 23. So let us multiply 23 with what? If we multiply, we get the answer 46. So exactly it is 2. So we have 2 moles. The molecular formula for potassium nitrate is, so what is the molecular formula for potassium nitrate? Options: KNO3, KNO, KNO2, KON. So any answers? Very simple. It's first option, that is KNO3, potassium nitrate. Calculate molecular mass of the compounds whose formula are provided below. That is C2H4. It is ethylene. Molecular mass of C2H4 is mass of 2 atom of carbon. Here you should know the mass of an carbon. So how many atoms we have? 2 atoms plus mass of 4 atoms of hydrogen. How many hydrogen atoms we have? We have 4 hydrogen. So let us multiply 2 with 12 because the mass of carbon is 12 here. So 12 into 2 plus 4 into 1 because mass of hydrogen atom is 1. So what you'll get the answer? It is 28 units. So molecular mass of C2H4 is 28 units. So you have a reaction here. Consider the reaction. That is, carbon combines with the oxygen. C plus O2 give rise to CO2. 18 grams of carbon was burnt in oxygen. So they are telling us 18 grams of carbon has been burnt in an oxygen. How many moles of carbon dioxide is produced? So we already know the atomic mass of carbon is 12. So if 12 grams of carbon burns with 32 grams of oxygen, it produces 1 mole of carbon dioxide. And they are asking 18 grams of carbon will burn, right? So if 12 grams will give you 1 mole, then 18 grams of carbon will give you how many moles? This is how you have to calculate. So standard is 12 grams of carbons will give you 1 mole of carbon dioxide. They are asking us 18 grams of carbon will give you how many moles? So when you cross multiply, you will get 1.5 moles of carbon dioxide. So 1.5 moles of carbon dioxide. What is the molar mass of NaCl? So you should know about the atomic mass. So what is a molar mass? So what is the atomic mass of sodium and chlorine? You should just sum up them. You will get the molar mass. So let us see. So molar mass of sodium chloride is, so sodium is 23 grams plus chlorine is 35.5. So when you sum up them, you will get 58.5 grams per mole. So this is a unit for molar mass, gram per mole. So you should write always. So it is 58.5 gram per mole. Write the name of expected compound formed between. So when you combine hydrogen and sulfur, what is the expected compound? Any answers? Hydrogen and sulfur. Secondly, nitrogen and hydrogen. Okay. When hydrogen and sulfur will combine, we will have hydrogen sulfide, H2S. When nitrogen and hydrogen will combine, we will have ammonia, that is NH3. Propose the formulas and name of the compounds formed between. So they have given some names of the elements. You have to tell the formula and the compounds. So potassium and iodide ions. Firstly, we have potassium and iodide ions. So what is the compound formed between these two ions and what is the formula for that compound? Secondly, sodium and sulfate ions. Lastly, you have aluminium and chloride ions. Okay. So first one, any answers? Potassium and iodide. Yeah, it is potassium iodide. When potassium and iodide ions combine, it results in formation of potassium iodide, Ki. When sodium and sulfate, it is sodium sulfate compound. Lastly, aluminium and chloride ions, it is aluminium chloride, AlCl3. Write the formula of the compounds. Write the formula of the compounds formed between. That is Hg2 plus Cl minus, Ba2 plus 2 minus 4SO. So here they have given you ions. You have to write the formula of the compounds formed between them. So firstly it is HgCl2. Always the valency will go in a cross form. The 2 will come below the Cl. This 2, Hg2 plus, will always come below the Cl minus. That is, we have a formula HgCl2. Now here Ba2SO 2 minus 4. This 2 and 2 will cancel out. We have the left one is, since 4 is not minus, so it will always be SO4. So it is, the formula is BaSO4, that is barium sulfate. Mercury chloride and barium sulfate. Give symbol for each of the following isotopes. So we have given you the atomic number and mass number. You should identify the element. So firstly, atomic number is 19 and mass number 40. So it is potassium. Atomic number 19, mass number 40. Secondly, atomic number 7, mass number 15. That is nitrogen. So you should have a knowledge of periodic table here. Thirdly, you have atomic number 18, mass number 40. It is argon. Atomic number 17, mass number 37. It is chlorine. Charge of one electron is 1.6022 into 10 to the power of minus 19 coulomb. They have given charge of one electron. What is the total charge on 1 mole of electrons? So very simple it is. They have given a charge of 1 electron. You have to identify the total charge of 1 mole of electrons. So when we say 1 mole, it is understood that it is equal to 6.023 into 10 to the power of 23. So just multiply 6.023 into 10 to the power of 23 with 1.6022 into 10 to the power of 19. So this is a total charge of 1 mole of electron. Which of the following correctly represents 360 grams of water? You have 4 options here. So which of these will correctly represent 360 grams of water? 2 moles of water, is it 20 moles of water, or 6.022 into 10 to the power of 23 molecules of water, or is it 3.022 into 10 to the power of 25 molecules of water? It is 20 moles. So here we have, yeah, Varsha, very good. It's 20 moles. So we have 18 grams is the mass of a water molecule. So just 18 into how much? You will get 360. So it is answer is 20 molecules of water. One unit or one atomic mass unit, that is 1 AMU, means, is it 1 by 12th the mass of carbon 12 isotopes or atoms? Is it mass of carbon 12 atom, or is it a mass of oxygen 16 atom, or mass of hydrogen molecule? So what is 1 AMU is equal to? They are asking. So any answers? Is it equal to 1 by 12th of mass of carbon 12, mass of carbon 12 atom, or mass of oxygen 16 atom, or mass of hydrogen molecule? So it is equal to 1 by 12th the mass of carbon 12 atoms. Yeah, Varsha, exactly. It is a option, 1 by 12th mass of carbon 12 atom. The value of Avogadro's constant is, so we have studied, right? What is a value? What is a constant value? 6.0 into 10 to the power of 24, 6.01 into 10 to the power of 22, 6.022 into 10 to the power of 23, or is it 6.022 into 10 to the power of minus 23? Exactly. So option C, Varsha, is right. Option C, that is 6.022 into 10 to the power of 23. Which of the following statement is not true about an atom? So we have given you 4 statements about an atom. You should find it out which is not true. Firstly, atoms are not able to exist independently. Secondly, we have atoms are the basic units from which molecules and ions are formed. Thirdly, atoms are always neutral in nature. Last, atoms aggregate in large numbers to form the matter that we can see, feel, or touch. So out of this, which is not true? You have studied about the atoms. So out of 4 options, which is not true? Okay. So it is the option 4. Atoms aggregate. Yeah, true, Varsha, right. Atoms aggregate in large numbers to form the matter that we can see, feel, or touch. We cannot see the atom, right? So it is not true. How many moles are present in 40 grams of He, that is helium? They have given you options. Is it 10 moles, 11, 12, or 13? They're asking, they have given you 40 grams of helium. How many moles are present in it? So you have to find out. So for this, you should have an idea about the atomic mass of helium. Okay, the answer is 10. So helium, yeah, very good. Varsha, it is A. See, helium is having an atomic mass 4. So when you multiply 4 into 10, that is, or else you divide 40 by 4. So how much you will get? That is 10. That is nothing but the number of moles present in it. So 40 divided, that is atomic mass of helium is 4. So number of moles is equal to given mass. What is the given mass? 40. So divided by actual mass. What is actual mass? 4. So what you will get? It is a 10. So 10 moles is the answer. So we'll come to the conclusion part. So in this chapter, you learned definition of atom and you stated the law of conservation of mass, listed some of the important features of Dalton's atomic theory, distinguished between the atoms and molecules, and define atomic mass and molecular mass, define the mole concept and molar mass. You have learned about atomic mass and atomic number and represent some molecules with the help of a formula, and you solve some of the simple problems based on various concepts. So these were some of the important questions we have discussed. You can visit to edurapid.com for few more questions and solve your doubts. If you have any questions, you can ask me. Any doubts or questions, you can ask me.